Welcome, lovely one. My name is Anthony Osemensa, also known as Sir Tony, popularly referred to as the Mathematics Doctor. Today's topic is going to be algebraic expression. So we are introducing you to the basic of maths. Let us start. Algebraic expressions comes from two separate words, which are algebraic and expression. Let me start with algebraic. Algebraic means involving variables or unknowns. So if you write any mathematical expression and you see variables in the form of letters or symbols, then that expression is an algebraic expression. For example, x plus 2. I can see a symbol or a variable or an alphabet called x. So since x plus 2 has an alphabet or a symbol or a variable, this is algebraic. Expression. Expression is any statement or any sentence written in mathematical form. X plus 2 is a mathematical statement or a mathematical question that qualifies x plus 2 as an expression. And since x plus 2 has a variable or a letter in it, it becomes algebraic expression. Let me give you one example also for algebraic expression. 3m minus 7a squared plus 5. This is an expression because it is a mathematical statement that I've written. In the expression, we have letters like m, a, which are representing the algebraic part of the expression. So 3m minus 7a squared plus 5 is also an example of an algebraic expression. Let me give you one last example of algebraic expression. This is also a typical example of algebraic expression. Why? The first thing is we see a letter called A in the question. The letter has made it algebraic. And then we see a statement or a mathematical question written. So the mathematical statement with variables or letters in it has made it algebraic expression. Remember, algebraic expression is because it is a mathematical question involving variables, letters, or symbol. Now, at this stage, after you've been able to understand the meaning of algebraic expression, let me now introduce you to some of the terminologies that are associated with the algebraic expression. Let's take this example of algebraic expression. 3x squared plus 5my minus 7. This is an example of algebraic expression since it is a question or it is a mathematical statement which has symbols or variables written in it. Don't forget that in algebraic expression you can still see real numbers. 3 is a real number, 5, 7 are real numbers. Now, let's introduce you to the first terminology. The first terminology will be the terms of an algebraic expression. Now, the addition and the subtraction signs are referred to as operational signs. They are the ultimate signs that shows you where the terms are located. The terms are the individual parts of the expression separated by the addition and the subtraction signs. Since there is an addition sign here, the first term becomes 3x squared. Since there is a subtraction sign here, the second term becomes 5my. Minus makes 7 also another term. So there are 3 terms in this expression. The second term I would love to introduce you to is what we call the variable. The variable can be a symbol or can be a letter used to represent an unknown number. A number that you and I, we don't know the actual value. Now, in this our algebraic expression example, we have x squared. The x is a letter, so it becomes a variable. My. The m and the y are letters, so they become variable. So these are the variables in the algebraic expression. And remember, they are used to represent unknown numbers. Let's go to the next terminology called coefficient. Now, a coefficient actually is a number that is directly multiplying a variable. When I say a number, I mean a real number. For example, 3 multiplies the variable x squared, making 3 a coefficient. Moving on to 5my. The my represents a variable. Since 5 is directly attached to my, which is to say 5 is multiplying my, then 5 becomes a coefficient. Now remember, coefficients are directly attached to variables. 7 has no variable attached to it, so 7 cannot be a coefficient. That brings us to the next terminology called a constant. A constant may be any real number that stands alone without a variable. Also, a constant is any number whose actual value is known. So, looking at the expression here, we can see that almost all the numbers are attached to variables, but -7 is standing alone. That makes -7 a constant. And if there is a negative in front of the constant, automatically the negative becomes part of the constant. So since -7 is with the negative sign, then we must say -7 is the constant. Let's go to the next terminology, which is the exponent or the power. Now in this expression, you realize that x raised to the power 2. The exponent shows the number of times that particular number or variable is being multiplied. So x power 2 simply means x times x. So this power can also be referred to as the exponent or the index. So any number having this exponent, that number is having a power. Powers could be real numbers and they could also be variables or letters. Now let's go to the last term, but that will not be the list. Now we'll talk about operational sign. From the beginning, you realize that operational signs play major roles in algebraic expression. You'll be seeing them often. Now the operational sign separates the terms. Okay, so addition and subtraction are the operational signs we are seeing here. But there are also operational signs called multiplication and division. Even though there is a multiplication here, but we have not visualized it. So multiplication, division, addition, subtraction becomes what we call the algebraic operational signs. Please, these are the terminologies in algebraic expression. Now let us go ahead and add and subtract some algebraic expressions in our calculation methods. Now, in this part of our lesson, I am now going to introduce you to addition and subtraction of algebraic expression. Now that you know what algebraic expression is, and you know some terminologies associated with algebraic expression, let me show you how to add and subtract. Add or subtract algebraic expression. It could be the two. Don't forget, from the previous lesson, we discussed that addition and subtraction are called operational signs or algebraic operational signs. If you want to add or subtract algebraic expressions, please note the following. You must make sure that your terms are like terms. Now let's see what like terms are. Like terms are terms with the same variables raised to the same power. I'll stress on that again. For example, 3x squared plus 2x power 4. Let's take an example like this. Obviously, the operational sign in between these terms is the addition sign. So 3x squared becomes the first term. 2x power 4 becomes the second term. These terms have something in common, which is our variable x. But remember, for the sake of algebraic expression, like terms must be raised to the same power. Even though the variables are the same, the powers in these terms are not the same. So this is not a like term. Let's take another example. 5m raised to the power 4 plus 2m raised to the power 4. Now, the terms are 5m to the power 4 and 2m to the power 4. This is a typical example of like terms. Why? Since m is raised to the power 4 in the first term, and also m is still raised to the power 4 in the second term, we then qualify these two terms as like terms because they have the same variables raised to the same powers. Don't forget, the 5 in front of the variable m is called coefficient. 2 is also a coefficient. That doesn't make the terms like terms. Remember, coefficient express how many of them we have. It doesn't show like terms. So like terms are terms with the same variable raised to the same power. Now that you know like terms, let's add and subtract. But remember, the same thing applies to subtraction. So if we have 17u power 2 minus 3u power 2, this is also like term. Why? Because the variables are u and the powers are 2. So it makes this expression and the terms like terms. Let's solve questions on the addition and subtraction. Now, in this segment, we want to simplify x squared plus x squared as part of our addition and subtraction of algebraic expression. Rightly said, the terms are like terms. Why? I have a variable x raised to the power 2, another variable x raised to the power 2, making it like terms. Now, if you want to add, please, after you have seen that they are like terms, continue to maintain the variable and their power. Now, how many of the x squared do we have? We have only one of the x squared, since the coefficient is 1. No coefficient means coefficient of 1. Now, let us see. I have 1x squared added to another x squared. I get 2 of the x squared. So the answer will be 2x squared. You can also take it this way. There is 1 here, there's another 1 here. 1 plus 1 makes it 2. I repeat my like term x squared. So this makes it x squared in the question. Final answer must also contain x squared. So the answer for this question is 2x squared. Now, in the second example, I have simplified 3b cubed plus 10b cubed minus b cubed. Now let's simplify this by analyzing the terms. The first term is 3b cubed. The second term is 10b cubed. And then the last term is b cubed. If you study, they are all b cubed, b cubed, b cubed. That is to say, b raised to the power 3. Since the variables and their powers are the same, this expression contains like terms. So we simplify with the help of their coefficients. 3b cubed plus 10b cubed. 3 plus 10 makes it 13. Minus 1b cubed makes it 12. So 3b cubed plus 10b cubed minus 1b cubed becomes 12b cubed. 12b cubed. So that becomes the final answer. Okay, let's look at the third question under addition and subtraction of algebraic expression. 3x plus 7x squared minus 5x minus x squared. Clearly, if you look at this question, you realize that even though the variables are all x, but their powers are different. The first term has a power of 1. When there is no power for a variable, the power is considered to be 1. So 3x has a power of 1. 7x squared, power of 2. Minus 5x, power of 1. And finally, minus x squared, power of 2. Since the powers are not the same, they are considered as unlike terms. So in this question, we have to first of all group like terms. This is how we do it. 3x is a term which is like to negative 5x. So it becomes 3x. Since the sign is minus 5x, I'll move it with a sign. So it becomes minus 5x. So I've grouped the like terms for x. Now I can see x squared. So let's group the like terms for x squared. Positive 7x squared. The sign is plus, so it moves with the 10. Then I have minus x squared. So I have grouped like terms. Now let's simplify based on their like terms. 3x squared minus 5x will be simplified. That makes it 3 minus 5, giving us minus 2. That is negative 2 with the x attached to it. When you come here, 7x squared minus x squared gives us 6x squared in the positive state. So it becomes plus 6x squared. Remember, I have positive because positive 7 minus 1 becomes positive 6x squared. Now, look at something here. Since x and x squared are not like terms, you can leave your answer this way. If you want to further simplify, then we would have to what? Write it such that we can change position for the positive to be at the first place and then the negative comes to the last end. So we can rewrite this one as 6x squared minus 2x. Also in mathematics, we can further simplify this by factorizing the common terms out. But when I get to factorization, I explain the method of factorization to you properly. So at this juncture of my lesson, I will leave my answer this way. Let's take a look at the next question. Okay, let's now go to our next question. In this question, we can see that we are simplifying 3m squared minus 5m cubed minus m squared minus 6m cubed. As usual, let us group like terms since the powers of the variable m are not the same. Now, I will consider m squared as my first like term. So I will head straight to 3m squared. So you write 3m squared. There is another m squared, which is minus m squared. So minus m squared. The m squareds are done. So we will now continue with the m cube. The first one will be minus 5m cubed. Minus 5m cubed. Then the next one will be minus 6m cubed. So minus 6m cubed. Now, checking from our arrangement, we can now simplify the various like terms. So 3m squared minus m squared will now give us 2m squared. Now we have minus 5m cubed minus 6m cubed. Minus 5 minus 6 will be minus 11, because minus 5 will also have another minus 6, which increases the negatives, making it minus 5 minus 6 minus 11. So minus 11m cubed. Now, since the m or the variable m has different powers, we will leave our answer this way. We can also do factorization further, but we will teach you the factorization in the next lesson. So this becomes our final answer for now. Now, let's take a look at the next question. 5pq plus 6mn plus 2pq minus mn. We have to group like terms. So the first variable is pq. So let's start with the pq. We have 5pq. And we have the next pq as plus 2pq. So plus 2pq. We go to the 6mn. So plus 6mn. Then finally minus mn. Let's simplify. 5pq plus 2pq gives us 7pq plus 6mn minus mn. Because of the 6 minus 1, we get 5. So plus 5mn. Since these two terms are not like terms, that is to say they have different variables, then we leave the answer this way. Let's take a look at the next question. 8a squared b cubed minus 3a cubed b squared minus a squared b cubed plus 10a cubed b squared. From this question, the variables are the same, but their powers are not the same. Let's group like terms. 8a squared b cubed. We have minus a squared b cubed as its like term. So we have minus a squared b cubed. The next term will be minus 3a cubed b squared. So we write minus 3a cubed b squared. The next term to it is 10a cubed b squared. So since it's positive, it becomes plus 10a cubed b squared. Let's simplify. 8 minus 1 gives us 7. So we have 7a squared b cubed. You repeat the variables with their powers. Then we have minus 3 plus 10 gives us positive 7. So plus 7a cubed b squared. Now if you check the variables, their powers are not the same. This is a squared and this is a cubed. B cubed, b squared. That makes them unlike terms. So we have to leave our answer this way. They are not like terms. As I said, you can factorize further, but we'll treat factorization in another lesson. Now that you know how to group like terms and simplify under addition and subtraction of algebraic expression, let me teach you one final rule you have to always abide or stick to when you are adding and subtracting. We have variables which are letters or symbols, and we have real numbers. Remember, when you are adding a variable to a real number, the answer will remain the same. For example, a plus 2. A is a variable, 2 is a real number. Since we are adding, they are still not like terms, or they are unlike terms. So we can't add. The answer remains a plus 2. Also, let's take another rule. When I have two different variables, for example, m minus n, since we are subtracting m and n, they are not like terms. So we will leave our answer m minus n, because we cannot add or subtract unlike terms. Let's take a final question. 3x squared plus 5. In this case, the variable is x squared. 5 has no variable. So we are talking about a term with a variable and a coefficient against a constant term. They are not like terms, so the answer will continue to be 3x squared plus 5. Now, with that being said, let's simplify this algebraic expression with all the rules I have taught you so far. The question is 5x plus 4 minus 4y plus 3x plus 2y minus 7. There are unlike terms, so let's group like terms. I have 5x as my first term. The like term to 5x is plus 3x. So plus 3x. I have a constant plus 4. So plus 4. We have the constant minus 7. So minus 7. They are the like terms for the constant. Then I have a variable y. So minus 4y. Minus 4y. Then plus 2y. Let's simplify according to their like terms. 5x plus 3x gives us 8x. I have 4, that's positive 4, minus 7 gives me minus 3. Then I have minus 4y plus 2y gives me minus 2y. Remember, I said the arrangement can change, but maintain the signs and the coefficients in front of them. So, since 8x minus 3 minus 2y are unlike terms, we'll leave our answer this way. Thank you. Now, finally, let's take a look at this question. M squared plus m squared. Don't forget, if you consider the terms, m squared are like terms. Now, some people may think because the powers are the same, when you add this, you get 2m raised to the power 4. No, you can't change the power under addition and subtraction of algebraic expression. The power must continue to be the same, even in the normal final answer. The power will still be 2. Why? Because m squared have the same variables, same powers. That makes them like terms. So the power for the final answer remains as 2. 1 of the m squared, another 1, making 2 of the m squares. Remember, this is leading us to our next topic called multiplication and division of algebraic expression. In that lesson, you will learn that the powers will change because the rule of indices will affect it. Same basis, multiplying must add the powers. So don't forget, in addition and subtraction, please, under like terms, don't change the powers.